Horizontal asymptotes appear in rational equations when the top side of the graph and the bottom side of the graph approach x values that are either reaching towards positive infinity or negative infinity without bounds. This is also referred to as the end behavior. Horizontal asymptotes act as a wall to the graph. They are always parallel to the x-axis. We can only have up to one horizontal asymptote. Horizontal asymptotes can sometimes be crossed. They will always be written as equations because horizontal asymptotes extend left and right, thus representing a horizontal line. Horizontal lines must always be written as an equation, so we'll use y equals a number. You will look at the degree of the numerator and compare it to the degree of the denominator. This will help you identify the horizontal asymptote. There's going to be 3 scenarios that we can run into while working with horizontal asymptotes. You need to write these down. The first thing that we could run across is if the degree of the numerator is less than the degree of the denominator. If this happens, that will result in a horizontal asymptote at y equals 0. The second scenario we can have is if the degree of the numerator is equivalent to the degree of the denominator. If this occurs, our horizontal asymptote will be located at y equals a divided by b, where a and b are the leading coefficients when the polynomial is written in descending order. The third scenario that we could encounter is if the degree of the numerator is greater than the degree of the denominator. If this happens, then our problem has no horizontal asymptotes. Let's take a look at example 1. For example 1, I'm going to find the degree of the numerator and the degree of the denominator. You need to remember that the degree is the highest exponent on our variable. So if I look at this first example, I don't have any variables in my numerator. So it's like I have an x to the 0, which means 0 is the degree of the numerator. And then I look at the polynomial in my denominator. The degree of that polynomial is 2 because that's the highest exponent located on the variable. So if I were to compare, I had a degree of the numerator, which was 0, and I had the degree of the denominator, which was 2. 0 is less than 2, so the degree of the numerator is less than the degree of the denominator. When this happens, we said we always end up with a horizontal asymptote at y equals 0. And I can tell that if I were to make a horizontal line at y equals 0 and extend it all the way to the left and all the way to the right, it gets really, really close to it, but it never crosses it. Let's figure out the horizontal asymptotes for example 2. For example 2, I look at the degree of my numerator. It happens to be a 1 because that's the highest exponent on my variable. Then I'm going to find the degree of my denominator. It happens to be a 2 because that's the highest exponent on my variable. Then I'm going to compare the degree of the numerator compared to the degree of the denominator. The degree of the numerator is a 1. The degree of the denominator is a 2. 1 is less than 2, so the degree of the numerator is less than the degree of the denominator. This results in a horizontal asymptote at y equals 0. If I were to draw a horizontal line going all the way to the left and all the way to the right, where y equals 0, my graph is getting really, really close to it, but it does not cross it. Looking at example 3, whenever we're trying to figure out the horizontal asymptote, I'm going to take the degree of the numerator, which is a 1 because that's the highest exponent on our variable, and the degree of our denominator, which is also a 1 because that's the highest degree of the denominator. So the degree of the numerator is equivalent to the degree of the denominator because 1 is equal to 1. Well, when this happens, our horizontal asymptote will be located at y equals a over b, where a and b are the leading coefficients of our fraction. So as long as they're in descending order, I can look at the front numbers. These are my leading coefficients, and I can get a 2 over my imaginary 1. So I would end up with y is equal to 2 divided by 1, which is the same thing as y equals 2. So my horizontal asymptote is at y equals 2. I can draw a horizontal line through the y value of 2, and I can see that my graph is going to get really, really close to it, but it's never going to cross it. Let's take a look at example 4. For example 4, the degree of my numerator happens to be a 1. The degree of my denominator happens to be a 2. So I have the degree of the numerator is going to be less than the degree of the denominator because 1 is less than 2. When this happens, our horizontal asymptote is going to be at y equals 0. If I were to draw a horizontal line where y is equal to 0, I can see that the end behavior of my graph is extending towards negative infinity and positive infinity. It's going to get really, really close to 0, but it's never going to cross it. Now, we said sometimes our horizontal asymptotes can be crossed. This is a scenario where it could be crossed because remember, whenever we're looking at horizontal asymptotes, we don't care about what happens in the middle. We actually care about what happens at the ends. This is our end behavior. Let's take a look at example 5. For example 5, I have a degree of 1 in my numerator and I have a degree of 3 in my denominator. So the degree of my numerator is less than the degree of my denominator because 1 is less than 3. Whenever the degree of the numerator is less than the degree of the denominator, our horizontal asymptote is at y equals 0. If I were to draw a horizontal line through 0, I can see that my graph is going to get really, really close to it, but it's never going to cross it. For example 6, I have a degree of 2 for my numerator, and I have a degree of 3 for my denominator. The degree of my numerator is less than the degree of my denominator because 2 is less than 3, so my horizontal asymptote is at y equals 0. Because I can tell that whenever I draw a line at y equals 0, a horizontal line, at the ends of my graph, it's going to be getting really, really close to that value, but it's never going to cross it.